The professional ideas and opinions expressed in this podcast are mine and do not reflect those of any current or past employers. Chris Van Buren, welcome to Make It So. I'm really excited to have this discussion because for the first time we're having somebody's actually down in the weeds creating these AI systems with us today. So, where I'd love to start, Chris, is tell us a little bit about your background. How did you get where you are? Take us on the journey a little bit.
Yeah, thanks, Robert. Really glad to be here. So I would say my profession is an AI engineer. I don't train the models that make AI great, but I build the systems and products around them. So I started doing AI and machine learning when I was at Duke, and then I started my career at Lenovo. And as soon as models like GPT-3 were coming out from OpenAI, I started telling everyone who was around me, hey, we need to start figuring out how to use these things. And so pretty soon I got thrust into just being the guy who, was in charge of how do we use large language models and what can we do with them. And so I started building RAG systems to basically be chatbots that could help us answer questions for customer support, things like that, traveling around to all the different conferences, and then working with some of our biggest customers and building agentic systems for them. Uh, then I had a high school friend who he had studied biology at the University of Michigan and had started a Alzheimer's drug startup out of some research there with a professor. And I think they had very, very interesting and promising early results. And a lot of what they had done was funded through NIH grants. And so he got very familiar with this problem of NIH grants are very difficult to write. They're a real pain, and many researchers are spending 40 or 50% of their time on them. And so once his
Wow.
once his startup failed, we decided, hey, we're going to go in on trying to solve this problem. So we spent a while trying to build that. We got up into, we built a product that was used by over 30 labs across many universities. And pretty soon after we really started picking up, the NIH unfortunately put out a policy saying that NIH researchers are not allowed to use AI to write their grants. And so that kind of forced us to shift our focus, and we ended up spending the next year working on AI document writing, not in the grant space, but in study planning and biostatistics.
Fascinating. I'm curious about a couple of things you said. So uh, we'll start first with uh, the NIH ruling that you're not allowed to use AI to write grants. That seems somewhat artificial. I mean, everybody uses interns to write grants, right? I mean, they're the ones who put pen to paper and start the process. And
Sure. Yeah.
um, so, what was it about? Was it just fear of AI, or there get too
Yeah.
many
So,
grant
so the
proposals, or what?
what they put out was a notice, and it said that due to the amount of AI tools that were becoming available, mostly ChatGPT and things like that, uh, I think and the reviewers for the NIH were just seeing massive amounts of grants come in. And we had talked to users, a lot of the same people who are writing grants are also reviewing grants, in a large part. And so
Right.
a lot of these people would say, yeah, I'm getting a lot of grant proposals that I just can tell off the bat are written by ChatGPT. There's not a lot of thought put into them. And that kind of showed us, when we were talking to these people, well, ChatGPT is not really getting the job done, and there does need to be a product that actually thoughtfully goes about how do we cite things, how do we make sure that what we're citing is actually good research and not just any paper that happens to exist online, and how do we actually make sure that the user, the researcher, is the one driving what is written and not just
Right.
wait,
Yeah.
letting the agent or the tool decide what they're proposing.
Yeah, but it sounds like your strategy came too late to convince the NIH that this was a viable model. Is that
Yeah, I think it's a bit naive. I think that there's really no way for them to tell, at least from our product, that there was any use of AI. And frankly, I don't think the way that our users used AI was unethical or anything like that.
right?
It really helped. Most of it was helping them navigate the massive amounts of NIH guidance about how to actually structure your grant, what's allowed in what section and not, when do you have to write certain sections depending on the type of grant you're writing, and just helping them get their ideas down into the right structure and format on paper.
Yeah, well, that had to be a very frustrating experience for you to spend all that time to have it yanked at the very end there.
Yeah, yeah, it was definitely unfortunate, and I think that's a problem that I'm passionate about is um, helping scientists and researchers. Hopefully they should be spending time doing research and not, winning funding.
Yeah, no, that's a laudable goal. So let me back up just a half a step here, or maybe it's a full step, and ask you, what is agentic AI? What does an agent do? Describe that process because we have a general idea, those of us in the lay public, that you create an agent, it can go do stuff for you.
Yeah,
What kind of stuff can it do, and what does it really mean to say agentic AI?
yeah, really important question to nail down. So I think in the most basic terms, an agent is an AI model, or you would call it an LLM, which I think everyone at this point is fairly familiar with.
Yeah.
And
Yes.
it's running in a while loop and has the chance to call tools. I think that's the most basic definition. So it rather than putting in one prompt and getting one output, we get to loop the model. And so it gets to first think about the problem that we're posing to it. And then it runs through another loop cycle and can then decide, oh, I want to call these tools that I know I have access to. And there's no magic around this really. It's mostly just the user gives a prompt, which I think we're all familiar with. It's just the instruction that we want it to follow. And the application layer appends things to that prompt that tell the model what tools it has access to. And tools, the agent or the model is going to just output some tokens or some text that says, I want to call this tool. It's just some structured text like JSON. And that is just going to go run a function. So, and it's just running some sort of code function that can execute something and then get back to that agent. Hey, here's the result of that tool call.
So a tool call might be, let me see if I've got this right, an example. Chat GPT, for example, I think I asked it something about my emails, and it said,
Hmm.
okay, well, I need access to your emails. Can you give me access to your emails? Which made me very nervous, I have to admit. But uh, is that agentic when it says I need access, I need an API to your emails so that I can go in there and search them and do what you asked me? Is that what we're talking about here?
Right. So, what the agent is telling you then is it doesn't see that it has a tool to access any emails, right? Behind the scenes, it's getting this note. Here are the tools you can do. A lot of that might be read files that you've uploaded or do a web search, right? Um,
Okay.
Once you connect your email through the application, it's then going to pop up for the LLM to see I have this tool about reading emails.
Okay. Okay. So, from your perspective, the hype versus the reality of AI, where do you fall on that spectrum of it's going to change the world? Anywhere from we're all going to live peacefully, happily ever after to we're all going to die. Those are the extreme thoughts that are out there to, yeah, it's just another tool. It's not going to change much. Life goes on. The truth is probably somewhere in the middle. Where do you fall on that spectrum?
Yeah, I think that overall, what I'm seeing in the market is there's huge investment now moving where it used to be mostly in model development and research and creating and training the best models to now we have very, very performant models, and you have all these industries saying we want to use these models. They can do tasks that last multiple hours. You can actually just create full applications out of the model capabilities. But mostly what we're looking at is every uh, frontier AI lab and the big tech companies and AI product companies, they're all investing in forward deployed engineering and customer support and making sure that they can take the great models that they have access to or that they've built and make them work at a product level for individual users. And that's going in and learning certain domains or certain workflows and making the models work for that.
So, there's another dichotomy that I hear a lot in the market and that I see written up is the dichotomy between a general purpose model, which,
Hmm.
you're looking at, can we make AI so smart that, we don't need to customize it? It has general knowledge about everything, super intelligence, if you will, versus no, really the way this is going to wind up is you're going to take LLMs, you're going to do what you're talking about. You're going to train them on specific issues that need to be addressed for this specific company at this specific time. Which way is it going? And do you see, general intelligence in the near future, or is that really a pipe dream? And I think about human beings, right? General intelligence, and yet we specialize, don't we? We
Sure.
have areas where we are really good and areas where we're not so good. Now, given the knowledge breadth of these models, you can do something beyond that, perhaps. But where do you fall on that spectrum?
Yeah. So I want to pick apart how you asked the question because I think this
Okay.
gets to a common misconception.
Okay.
Um, so a lot of what I'm doing at this point is not training models at all. I'm not ever changing the weights of how the model actually works, and
Okay.
I'm not gathering a big data set and running it um, to train that model. Uh, where I think basically we are now is uh, we have these great frontier generalizable models. They can, and by the way, they're multimodal, right? They can see images and they can sometimes dissect audio and they can obviously do text. And so just the scaling laws of how the capabilities scale as they get bigger just means that it's better to have one model that's really good at everything. And if you look at like how the frontier labs have done this, basically Google DeepMind a year or two ago said, "Hey, we're going to stop all the work that we're doing on all these different models. We have a bunch of different teams, and we're consolidating it, and everything is going into Gemini. We're only building one architecture, and it's all Gemini." And the labs have gone similar ways because just having one model that can do everything, it scales exponentially. Uh, so I think there's a lot, I think most capabilities will go into just using a generalizable model. I think there will always be places where it helps to have a domain specific, maybe fine-tuned model, especially in maybe non-generative capabilities, such as if we're thinking about search, or we want to take, we have a vast collection of documents or web pages, and we want to be able to search over, hey, I'm looking for a certain topic. That's not a generative task, right? That's just a kind of a mapping task. And so
Yeah.
it
Yeah.
helps if you are in the biomedical space to have something that can map in the biomedical space and understands those terms and give you a distributed layout rather than a generalized model might map almost everything in the biomedical space just in one clump, right? And not really be able to
Gotcha.
differentiate.
Okay. So that's that is a level of training, though, right? You're taking a generalized model and you're making sure that it is up to speed on specific, the vernacular for whatever that discipline is. Is that right? Or
There are a couple different levers, I would say. One is you can change the actual weights of the model, right? And so that is if we put the same exact thing as input to the model, and then we change the weights, we're going to get a different thing out, right? Um, so that I think we can leave to the frontier labs. They're going to make generally very good models. I think that the other lever is the context or the input that we give to that model. It's really all one giant prompt, right? And so, as an application or product developer, your job is to uh, take the user prompt and then uh, give the model around that more context to do its job. So that can be here's access to tools. A big paradigm is skills, and so these are literally just files of text that explain in English how we want the model to go through this process that the user is trying to kick off. And so it's really just how can we give more and more context to the model so that way it behaves in the way that we want it to. We don't actually have to change any weights or train the model anymore.
interesting. Okay. All right. I think I got that. So, uh, the other term that I've heard thrown around a lot is harness. And can you explain what a harness is? My understanding is that an LLM without a harness really can't do much. It can answer questions. It can,
Mhm.
generally give you answers through prompts. But the harness, is that the tool that allows you to provide that context?
Yeah, the harness is basically the application layer around the LLM that's going to give it the context, right? And so it's the tools that are available, it's memory. So sometimes when a user asks a question, uh, the agent may have stored memories, which it can call through a tool just to say, hey, I learned this thing about the user. So if you're a user of ChatGPT, for example, and you go ask it something about yourself, like, hey, what do you know about me? It will actually remember things about you, even if it's not in that chat. And that's because it has this database of memories about you. And so the harness is feeding it relevant things to what the user has asked. It's all just
Okay.
context that's added around the user input.
Okay. Okay. And there's those aren't really that's sort of standard programming. That's not AI. That's just sort of here's how you access the tools AI.
There is AI to it because a lot of it is dynamic to what the user is asking about, right? And so if the user says, um, there were, let's say we're working on, let's say we're a doctor and we're researching some disease, right? Well, first thing that's going to happen is the harness is going to take the user's input and use AI to search through all our memories and see, hey, is there any memory about this disease or about what we're trying to do here, right? We also have a collection of skills, which are just files describing how we want the agent to perform this task. And so we can use AI to very quickly say, this is the request from the doctor, and do we have a skill that we want to feed into the context to tell the agent how to perform this? So yeah, there's AI in the harness itself
Okay.
because we have to deal
Okay.
with the natural language inputs that the user gives.
Okay. Okay. So, given your perspective on this and the context that you have as a human being, where do you see AI making the most difference in healthcare? I mean, have you thought about, gosh, where is it going to have the biggest impact, and or do we know that yet? Is that something that we'll learn over time?
Yeah, healthcare is a really big space, and I won't begin to understand, I won't pretend to understand all of it. The problem I'm really familiar with, I think, is uh, documentation and planning and all of these kind of uh, scientific yet mundane in their bureaucracy and formatting issues that scientists are dealing with. So concretely, what I've seen from my users is that there are researchers at universities and labs who are spending sometimes half their time writing for funding and making sure that their lab isn't going to die within the next year and everyone that is in their lab out of a job. So this is, I think, just it's a huge inefficiency of our system of funding science, I think.
Gotcha. Okay. And so is that where I know that you may not be able to tell us everything about what you're doing now since you work for startups and not all of that's going to be public knowledge yet, but what kinds of things are you working on now? What's occupying your time?
Yeah, right now I'm working on basically helping scientists and researchers plan their studies. So what we're looking into is uh, mostly our users, if they plan their study poorly, then they're in this big organization. There are a lot of pieces who are moving based on the plan. And if there's a mistake, it's going to cost many months to fix,
Yeah.
and it's going to send people off in the wrong directions, right? And so what we're trying to do is take a look at an organization's or an enterprise's past history of how they've planned studies and the amendments that they've ended up making on those studies when they made mistakes, and
Hmm.
identify and basically build up this agentic memory of, hey, here are mistakes that we've made in the past of when we plan similar studies and calling out for our users, hey, you're making a similar mistake that someone who's maybe no longer at the company, so we lost that organizational knowledge, but it's still
Right.
there in the records, right? So helping them identify that they're about to make a mistake and we can fix that right now rather than wait and have a costly error.
So essentially, the idea is to dramatically improve the efficiency of developing and running scientific studies. Is that a good
Yes.
summary of what you're doing? Yeah. Okay.
Yep.
Cool. Um, Now, as a curious baby boomer, I'm going to just ask some which may be elementary questions about large language models in general for our listening audience. And number one on that list is how much do you share with large language models? Are you keeping it close to the vest? Do you open up? What's best practice there?
Uh, I feel like I have a pretty high level of trust, but I understand where my large language model is being inferenced, and I change where I change what model I'm running and what application I'm using depending on what I'm talking about. So, for example, I downloaded this app that can run small models locally on my computer, and so it never hits the internet. It doesn't ever go to a model provider or an application outside of my computer. And mostly I actually just use this on airplanes, so that way I don't have to pay for the Wi-Fi to use
Yeah,
AI. Um,
yeah,
but
yeah.
now that we're getting Starlink on United, maybe I won't use that as much. Um, yeah, but I think overall, you know, I wouldn't share anything highly personal, especially sensitive information that could lead to identity theft or any terrible thing
Yeah.
like that. But I think I generally would treat it like maybe a neighbor, and I would share personal feelings with it and things like that.
Yeah, yeah. Okay. All right. Interesting. So, the models that are out there now, are they roughly equivalent, or do you have a favorite, or do you have a favorite for one task and versus another? How do you think about the models in general, the large language models?
Sure. Yeah. Uh, I think the frontier is always changing, and there seems to be a seesaw between
Uh-huh.
OpenAI, Anthropic, and sometimes Google. So it's hard to always be, keeping track with uh, what model is best. They're all very capable at the forefront right now. Really, the way I think about models when I'm building is uh, I think two dimensions. One is model size, and so bigger model, it's smarter, but it's also going to be slower and more expensive, right? And so
Hmm, okay.
for small tasks, you can use a smaller model, and that can be from a frontier lab, or it can just be an open source model, and there are very fast inference uh, APIs that you can use to just bring that into your application. Um, so I think that's always good to be aware of. Uh, and then the other is how good is this model at using the tools and the interface that I've provided in my harness. Um, so if you think about, ChatGPT or OpenAI's model, it's very similarly capable to Claude's model, but they're actually trained to perform very well in, Claude is trained to perform well in the harness that Anthropic gives it, and the same for GPT models in OpenAI's harness. They're actually trained, during their training using reinforcement learning to use the tools that OpenAI is giving it to, say, write files or perform code and things like that. And so, as a developer, thinking about what tools I'm going to give it and how I'm going to show it, its context in my harness, I have to be aware of what works with this model and what doesn't work with another model.
Okay, very good. Uh, and you've raised another issue that I hear about a lot, and that is what of the open source models? Is that something that the average user can run into? Is it less expensive to use the open source models? How do you access them?
Hmm.
What's that about? I know that there are some Chinese models that are out there that are open source. And I just give us an overview of that space.
Sure. Yeah, I think it's really important to keep open source models in mind, especially if you're developing an AI product, because they can be much, much cheaper, orders of magnitude cheaper than frontier models from OpenAI or Anthropic, and be equally or near performant on tasks that I would say most tasks. I think if we're talking about coding or very distinct or complex tasks where there's really, every piece of 1,000 files has to be correct or this thing's going to break, then I think it's time to use a frontier model that's proprietary. But in many cases, especially a lot of what I've been building is not generating code, but it's generating documentation and planning. I think that the open source models in many cases are very performant and they can be much, much cheaper. So that's really important to keep in mind. In terms of accessing them, you can obviously host them yourself. So you can use, your own computer and GPU, or you can go to Bedrock or on AWS or other. I'm sure that each cloud provider has a solution for this. As well as if you're really just trying it out and you're not scaling in production, there are web applications that make it very easy. There's one called Grok, GROQ, and one called Cerebrus. They've actually built custom hardware that's not a GPU that's very fast at inferencing transformers, and so these are really good places to start and get very fast uh,
Okay.
open source models.
Do you, for the average user, the person that's playing around with, Chat GPT or or one of the other frontier models. Does it make any sense at all uh, from a cost perspective? Because all of them
Mhm.
are subscription models now, right? And
Yeah,
does it, from a cost perspective, does it make sense for the average user to familiarize themselves with an open source model that might be able to do everything they need to do at a much lower price? Is that a strategy that can bear fruit for the
sure.
average guy?
Yeah, I think that's pretty sensible. Like I said, I have an application on my computer, and there are many out there where you can run an open source model on your own computer. You could buy your own hardware, and that's a one-time cost instead of a subscription cost if you wanted to run larger models. But yeah, in many cases, if most of your work is summarizing things, writing emails, etc., I think that's very doable and sensible.
Okay, interesting. And where would one go to learn about how to do that? This is a very selfish question for me now, but
I can try. I forget what the application is called on my computer. Why don't I look it up after and
yeah.
maybe we could put it in the notes.
Okay, that sounds good. That sounds good. So, what's next for Chris Van Buren going forward?
Yeah, so I think that what I'm really passionate about and what I've been doing for the last couple of years is working with domain experts. Really, I love working with the users who I've worked with. They're all super smart, impressive people. And learning their workflows, their patterns, what pains them during the day, and building agents for that. Agents that can do these long running, high stakes tasks for, very domain specific or complex applications. So, basically, as I look forward, that's what I want to tackle and continue to dive into.
Okay, perfect. And now, do you see, uh, the Make It So moniker is about, okay, we've talked about this for ages, about fixing healthcare, about how it's broken, about how it's unsustainable. Do you see the path to better viability? And I'm asking you something that, is impossible for anyone to answer. So I'll take, please don't feel overwhelmed by the question, but
Sure.
do you see improving efficiency as the number one way that AI is going to help healthcare? Do you see diagnostic support? Do you see the work that you're doing as speeding up the science of medicine? Where do you see the one thing that's going to help us make it so? And what we're trying to make so is affordable, quality healthcare.
Yeah. Yeah, I think on one aspect there is the efficiency. I would say this is probably uh, not going to solve our problems, but probably make them a bit better or manageable. Um, you know, Besides research, I've talked to doctors who, have so much back office work that they're just, they're looking into AI applications to help them with that now. Um, so I do think that there's definitely that vector. I think it's obviously very, very exciting what can be done on the uh, coming up with new drugs or understanding molecules and understanding the human body and biology more with other types of AI models like AlphaFold and things like that.
Yes, of course.
So
Yeah.
uh, that's a bit out of my domain, and but I think that looking at how that's gone, I think that there's huge investment going on there, and that's obviously that has the opportunity to really change the game in terms of longevity and human health.
Well, I really appreciate your time today, Chris. I think we're going to wrap it up there. And Chris Van Buren, AI engineer extraordinaire, appreciate your time and thank you for being on the podcast.
Yeah, thanks. This was fun. Appreciate it, Robert.
Okay. All right. Take care. Bye
Bye.
bye.